Hello, 7th grade. Today we want to talk about inequalities. And even though we might not have used the word before in class, it's something that you probably are quite familiar with. An inequality is a statement which says that things are unequal to each other. They're not equal. So rather than having an equation where we know that one side of the equation is equal in value to the other, we want to talk about what happens when they're not equal in value. We do that using greater than symbols and less than symbols. So if we have something that's greater than, then that information that we're reading, like we read our words from left to right, the first set of information would be greater than. That means we want this open towards the first piece, would be greater than the second. And less than, then we want it facing the other way. That shows that the first information is smaller. This piece would be less than that amount. We can also have greater than or equal to, which means we might include the number we're talking about, and that's when we would have the second little line underneath it, like half of an equal sign, and sometimes it's slanted like this. Either of those symbols are okay. So with less than or equal to, then again we want to have the less than symbol, and we will have half of an equal sign, either straight underneath it or following the slant. So when we graph things on a number line, remember that we'll have a number line, we might have positive or negative values. And if we're graphing just one point, if we have a solution that maybe said that x equals -2, we solved an equation and we found a value that said x equals -2. If that were the case, then we would go on a number line to that particular point, and we would put a dot there to represent that this is the particular value that we're talking about. So a dot at the value -2 represented that that's what our variable equals. So when we're graphing with inequalities, we also are going to be dealing with all of the numbers, not just what we're talking about. For example, maybe if we have a solution x is greater than 4, then we can't just put the number 4 on a number line. We want to include things that are bigger than 4. So 5 would be included, 6 would be included, 7 would be included, 4.1 would be included. All of these values that are greater than 4. But the less than or greater than symbol versus the less than or equal to and greater than or equal to symbol give us different ways of graphing, because here that would exclude the 4, for example. If x is greater than 4, that means that x can't actually be 4 to be an answer, so it excludes that point, and we draw that with an open circle. If we do want to include, if we had maybe x is greater than or equal to 4, then on a number line we're saying that that's inclusive. It's saying that that point also is allowed, and we would write that in with a closed circle when we're graphing it on the number line. So our number lines, we want to think about them having positive and negative numbers, that they're drawn with equal intervals, meaning that we wouldn't have a number line and have 1 and then the next be 7 and the next be 420, and those all be equal distance apart. We want to represent the same amount between each point, and have open arrows on the ends. So we want to show that those number lines are going on forever in both directions. But like we said before, because we have more than just one point that's being included, we want all the values which are greater than or equal to 4. We have to think about which way on the number line we would be including. If you have your variable set up on the left, like we have here, the x is written on the left, then we can kind of think of these little shortcuts. If this little arrowhead appears to be pointing towards the right, so a greater than symbol or a greater than or equal to symbol, then we're also going to shade the line to the right of the value that's in the inequality. If it was set up with a less than, for example, y is less than -2, then if our variable is set up on the left side, then when we look at this symbol, the arrowhead appears to sort of be pointing towards the right when we use, the arrowhead appears to be pointing towards the left when we use our symbols, and so we're going to shade on the line towards the left. So let's talk about what is it that means. So when we look at this, it says x is less than or equal to 4. So we want to go to our number line and we want to Put arrows on both ends to show that this is a number line going forever in both directions. And we can show just the value 4 since we're doing just a basic sketch here. And we're saying that it's okay to include the number 4 because it says less than or equal to. So here I'm representing that our x could equal 4, but we also want to say that it could be any number that is smaller in value. So we're shading towards the left because those are values that are smaller than 4. And so we're saying that x could be anything that is 4 or smaller, and it would be okay. For example, 2 is smaller than 4. 0 is smaller than 4. Negative 100 is smaller than 4. So take a second, pause the video, graph the second one, and then we'll check it. So we want to put our arrowheads on both sides. We want to represent negative 3 here, and this time, rather than drawing a closed circle, we need an open circle because we're saying it has to be a value that is greater than negative 3. So anything all the way up to negative 3, negative 2.999 repeating, but not actually including the value of negative 3. And then anything that's greater in value, so negative 2, negative 1, positive 20, positive 1,000,000, any of those we could plug in for a value of x to make this piece true.